Hello everyone. In this video I will continue to do some final review and I'm just work on the final exam review assignment on Alex. Okay. Alright, in the previous two videos I already studied the first 10 questions. First 10 questions was about were from section chapter 5. And next 10 questions from 11 to 20, they're all from chapter 6. As you remember, chapter 6 is from, this is about how to draw the graphs of trigonometric functions and also in the inverse trigonometric function. Okay, anyway, all right, let's look at this question. The question number 11. Graph the trigonometric function y is equal to 1 over 2 sine x, okay? And to graph it, we should plot all points corresponding to x-intercepts, minima and maxima with one cycle, then click on the graph a function button. Okay. So first of all, y is equal to 1/2 sine x, right? We know that sine 0 is 0, right? So when x is equal to 0, we get y is equal to 1 over 2 sine 0, which is 0 again, right? Okay. So I'm just trying to find some critical points. Okay, when x is equal to pi over 2, sine pi over 2 is 1, right? That's why we get y is equal to 1 over 2 sine pi over 2, which is sine pi over 2 is 1, so we did 1 over 2, it makes 1/2. Similarly, x is equal to pi, not 0. X is equal to pi gives y is equal to 1/2 sine pi, and sine pi is 0, right? So it is 0. Next, when x is equal to 3 pi halves, y is equal to 1/2 sine 3 pi halves. And sine 3 pi halves is -1. So 1/2 times -1 is -1/2. Lastly, x is equal to 2 pi. So y is equal to 1/2 sine 2 pi. Sine 2 pi is 0. 1/2 sine 2 pi is again 0. Okay, after getting that, let's put some points here. What are the points? X is 0, y is 0, right? From the first part. Let me, okay. X is 0, y is 0. Plot that point. As you see, we plotted that point over there. Next point, x is pi over 2 and y is 1 over 2, right? 1 over 2, plot that point. As you see, we got the other point over there. And next, pi and 0, right? Yes, pi and 0, plot that point. Next, 3 pi halves. Okay. 3 pi over 2, and as you see, y value is -1/2, right? -1 over 2. Plot that point. And last point is 2 pi and 0. Plot that point. As you see here, we plot all the points, right? After plotting that, just click on graphing function. This is the graphing button actually. And let's check our answers. Correct. Okay. This is how you do it here. But already we know that whenever we have 1/2, the amplitude will be 1/2, right? So we are just compressing our graph 1/2 units. Okay, let's go to the next example. graph the trigonometric function. All right. So 2 cosine x minus pi over 3. All right. So now we gotta be careful. We can always actually use our, methods whenever we have a number inside the parentheses. It means, so phase shift is pi over 3, right? So we have to shift the graph right to pi over 3 units and multiply it by 2. Okay, maybe I can do that way this time. So here, what is the phase shift? So phase shift is set whatever we have inside the parentheses, right, to the 0. X minus pi over 3 is equal to 0, which gives x is equal to pi over 3. So we are shifting everything to the right. Okay, pi over 3 units to the right. And there is also 2, right, in front of cosine, so we are going to stretch everything. Normally when on 0, right, when x is equal to 0, cosine 0 is 1. So we are going to take 1, shift it to pi over 3 units to the right. And then we are going to stretch it by 2 units. It will be going 2. So our new point is pi over 3 comma 2, right? You see that? Can I draw it? Maybe I can draw it. Okay. Yes. And then our next crucial point was pi over 2, right? Cosine pi over 2 was cosine pi over 2 is 0. We are gonna shift it to the right, pi over 3 units to the right. So pi over 2 plus pi over 3 makes 5 pi over 6. And we are gonna stretch it by 2, but since it is 0, you don't need to stretch it. So 5 pi over 6 is this point. Then next, maybe I can use my mouse for that. Yes. Our next critical point was cosine pi, right? Cosine pi is -1, but we're going to stretch pi over 3 units to the right. So pi plus pi over 3 is 4 pi over 3. So 4 pi over 3 is here. And cosine pi is -1, but we're going to stretch it by 2 units, so it will be -2. Okay. And next will be cosine 3 pi over 2 is 0. So 3 pi over 2 plus pi over 3, right? We're going to shift it to the right. So 3 pi over 2 plus pi over 3. If you have the common denominator, 9 pi plus 2 pi, 11 pi over 6. And the cosine 3 pi over 3 is 0. So if you stretch it, it will be still 0. So 5 pi over 6 is here. 11 pi over 6 is over there. And lastly, 2 pi, shift 2 pi over 3 units to the right. It will be 2 pi plus pi over 3. It will be 7 pi over 3. And the value will be again 2, right? 7 pi over 3 is here, right? Be careful. Yes. Let's double check. Okay. This is our function. Correct. Yes. We just applied the transformations we have here, right? The first one is shifting pi over 3 units to the right. The second one is stretching 2 units. Okay. Next one. Find the phase shift, period, and amplitude of the function. Okay. All right, let's make a new page. All right. So okay. Phase shift. To find phase shift, we have to look at the parentheses, right? Inside the parentheses. So phase shift is and set it equal to 0. So for phase shift, pi x plus pi halves is equal to 0. Let's solve this, right? So pi x equals minus pi over 2. And I can simplify those pi's. X is equal to negative 1/2, right? So phase shift is negative 1/2. Let me use this keyboard this time, negative 1/2. Okay. For periods, it is 2 pi. This is cosine, right? So it is 2 pi over b. And b is the number inside the parentheses in front of x, right? So 2 pi over b is 2 pi over, so b is a pi, right? That's why it is 2. This is period. This is phase shift. And amplitude will be the absolute value of the number in front of cosine, which is 1/2, right? So amplitude is absolute value of 1/2, which is 1/2. Okay. So period is 2 and amplitude is 1/2. Let's check our answers. Correct. Cool. Okay. Let's move. Next question. Write an equation of the form y is equal to a sine bx or y is equal to a sine a cosine bx to describe the graph below. Okay. All right. This graph looks like the cosine graph, right? Cosine graph, but stretched 4 units. That's why, and to stretch it vertically 4 units, I have to multiply cosine with 4x, right? But furthermore, actually amplitude is 4. We can also maybe find from there, right? Amplitude is 4. That's why a small a should be 4. And what is the period here? So if you look at the period from negative 2 pi to 6 pi, so period is 8 pi, right? So period is 8 pi. So 8 pi is equal to 2 pi over b. If you solve this equation, what do I get from there? If I do have cross multiplication, b is equal to 2 pi over 8 pi. This is 8, guys. Yes. If I simplify the pi's and 2 over 8, it will be 1 over 4. So our function will be y is equal to, come on, 4 cosine 1 over 4 x. Y equals 4 cosine 1 over 4 x. Should I put the parentheses? Maybe it is better to put a parentheses. Let's check our answers. Correct, yes. Okay, last question in this video. Question 15. What are the domains and range of the following functions? Cosine x. Okay, cosine is defined everywhere, right? The set of all real numbers. And if you look at the cosine, cosine takes only values between -1 and 1, right? That's why the range is from -1 to 1. Cosecant x. Cosecant is 1 over sine. And so 1 over sine is actually 1 over sine is not defined when sine is equal to 0, right? Because we will get 1 over 0. And when sine is 0 at 0, pi, 2 pi, 3 pi, and so on and so forth. So the domain of this function is all real numbers except multiples of, except integer multiples of, I think, I cannot see the whole answer. Yeah, except integer multiples of pi. And cosecant x, actually, what about the range? Range of sine is between 1 to 1, right? So if you flip that, to get cosecant x, so your range will be all the real numbers except -1 and 2, except the numbers between -1 to 1. So the set of real numbers less than or equal to -1 or greater than or equal to 1. No, not this one. This one. Okay. Tangent x. Tangent is sine over cosine, right? That's why it is not defined when cosine is 0. And when is cosine 0? Cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2. So all real numbers except odd multiples of pi over 2, right? Yes. And what about the range? You know, if you remember the graph of the tangent, the tangent can take any real numbers, right? From negative infinity to infinity, it's a set of all real numbers. Okay, we have something wrong. Let's check, double check. Okay, cosine domain is the set of all real numbers. Yes. Range is, I picked the wrong one. Range should be all real numbers from -1 to 1, right? Yes. I said that one, but I selected the wrong one. Okay, anyway. Let's check again our answers. Yes, correct. All right. Okay. So we have done first 5 questions. In the next video, I will be doing next 5 questions. Okay. So see you in the next video.